Okay, so in this next problem we have a story problem that says an airplane flies from Naples, Italy in a straight line to Rome, Italy, which is 120 kilometers north and 150 kilometers west of Naples. How far does the plane fly? So the first thing you're going to want to do is draw out what the picture is asking you in order to get a better idea of what you're meant to do. So let's just say that Naples, Italy is right here, because that's where we're starting. And so this plane is flying 120 kilometers north of Naples. So this is going to be 120 kilometers north. And I'm just doing a standard compass where it's north, east, south, west. So we're going 120 kilometers north, and then we're going 150 kilometers west. And it wants to know the distance between Naples and Rome. Well, because we're starting in Naples, we can think of that on a graph as 0, 0. Because that's our starting point, and the origin of the graph is always the kind of where you're starting at, or yeah, where you're starting from. Now, because we're going 120 kilometers, 120 kilometers north and 150 kilometers west, we can think of this kind of like a graph, for example. So this 120 would be our y value, and this 150 would be our x value. So we go 120 for the y. And if we're thinking about it on the, if you're thinking about it on a graph, you might be tempted to say that this is negative 150, because if you're looking at it in a graph, going west is like going negative. But because this is a distance is always going to be positive. So we would just write 150. And now we have 2 points. We have an x1, a y1, and an x2, and a y2. So now, since we want to find the distance, we just do the distance formula. And that's the other reason why you should put 150. If you put negative 150, because the distance formula involves squaring, and because there's a 0 here, you will always end up with 150 squared, if that makes any sense. I'll walk you through it in the distance part. So now in the distance part, we will rewrite our distance formula. D equals the square root of x2 minus x1 squared plus y2 minus y1 squared. So our x2 is going to be 150. And that's going to be minus 0, which is our x1. And then that's going to be added to 120 minus 0 squared. So now you see, if we do it with a positive 150, 150 minus 0 is still 150, and we just do 150 squared. And that will give us a positive number. If we did negative 150, then we would have negative 150 minus 0, which would be negative 150, and negative 150 squared would still give us a positive number. So in this problem, because your 2 points are 0, 0, it wouldn't actually make such a big difference if you wrote negative 150 here, but I would just write positive 150, since this is a distance and you can't go a negative amount of distance. So 150 minus 0 is 150, so we have 150 squared, and then 120 minus 0 is 120, and that's going to be squared as well. So if you don't know these off the top of your head, you're going to want to pull out a calculator for this. So 150 squared is 22,500. So we have the square root of 22,500 plus 120 squared, which is 14,400. So then we do 14,400 plus 22,500, and we get the square root of 36,900. And then when we do the square root of 36,900, we get that Naples and Rome are approximately 192.09 kilometers away from each other. Okay, so in this next problem, we're told to use the midpoint formula to estimate the sales of Big Lots in 2005, given the sales in 2003 and 2007, and we're meant to assume that the sales followed a linear pattern. So in 2003, they made $4,174 in millions. To be honest, I don't really know what that means, why they write it in millions, but they give us a number that's in the thousands. Same thing with the year 2007. It's 4,656 millions of dollars. So either way, the specifics of that don't really matter. What we need to know is that we can take this and put this into ordered pair form. So in 2003, we can write that as our x value, because I'll explain why in a second. If you were to graph a company's sales on a Cartesian plane, hold on. Your years are always going to be on the x-axis, and the sales will always be on the y-axis. So, in the x-axis we have 2003, and in the y-axis we have 4,174. And for the next point we have 2007 and 4,656. And it wants us to find the midpoint. So because the midpoint will give us the year 2005, and then it will give us the estimated amount of sales of that year. So if we go over here, we have the midpoint formula written down: x1 plus x2 divided by 2, comma, y1 plus y2 over 2. And that will give us the year and the sales they had in that year. So our x1 is going to be 2003, and our x2 is going to be 2007, and that's going to be over 2. And then for our y value, we're going to write down 4,174 plus 4,656. And then that's, of course, going to be over 2 as well. So 2003 plus 2007 will give us 4,010. And that's going to be over 2. And then 4,174 plus 4,656 is going to give us 8,830. And then that's going to be over 2. And 4,010 4010 divided by 2 is 2005, which is the year we're looking for. And then 8830 divided by 2 is 4415. Meaning that, assuming that the sales pattern of Big Lots is linear, in 2005 they had made $4,415 millions of dollars. Okay, so in this question the directions we're given are: the polygon is shifted to a new position in the plane. Find the coordinates of the vertices of the polygon in its new position. And they tell us that these are the vertices of the original triangle. We have -1, -1, -2, -4, and 2, 3. And they say that each of these points are moved to the right 2 units and up 5 units. So, in order to figure out where the new vertices would be, all we have to do is perform this action on these points here. So for example, let's take the point -1, -1. Well, if we're moving it to the right 2 units, we are really just adding 2 to the x value here. So -1 plus 2 is going, let me write that better. -1 plus 2 is going to give us 1. And -1 plus 5, because it's going up 5 units, we'll be adding 5 to the y value. -1 plus 5 is just 4. Alternatively, you could count the spaces and move it over like that. Like I could say, okay, right 1, right 2, up 1, up 2, up 3, up 4, up 5. And then that still gives us the point 1, 4. It's just 2 ways to do it. Now, with this other point here, -2, -4, so let's write it over here, -2, -4. We're once again going to be adding 2 to the x value and getting the point 0, and then we add 5 to this, the y value here, and we get 0, 1. So we go up there like that. And then finally for our last point, which is 2, 3, 2, -3, I'm sorry. We're going to add 2 to this side, to the x value. That's going to give us 4. And then we're going to add 5 to the y value. -3 plus 5 is 2. So we go over to 4 right here and go to 2 right there. So this is what our triangle would look like after the translation. Okay, so in this problem the directions are exactly the same, except it gives us new coordinates and a new translation. So this time we're given 4 coordinates instead of 3, and those coordinates are -7, -2, -2, -2, -2, -4, and -7, -4. And the translation is going to be up 8 units and to the right 4 units. So let's break down this problem into 2 steps. First we're going to graph these vertices, and then we're going to do the translation. Because the directions are the same as the last problem, I want you to pause the video and try this problem on your own, and then we'll come back and see how you did. So the first thing you're going to want to do is graph all 4 vertices on the plane here. So our first point is -7, -2, so we go to the left 7 from the origin. So that's 1, 2, 3, 4, 5, 6, 7, and then we go down 2. Like that. So that's going to be our first point, and our second point is -2, +2. So we go to the left 2, and then we go up 2 to right about here. And then we go to the left 2, and then we go down 4. Right about there. And then we go to the left 7, so 1, 2, 3, 4, 5, 6, 7, and then down 4. So right about here. and then we just connect those points. And these points might not look the straightest, but just assume that they're straight for the purpose of this problem. So we're going to be shifting it up 8 units and right 4 units. So if we're going to the right on the x-axis, that means we're going to be adding 4 to whatever's on the x value. And if we're going up 8 units, that means we're going to be adding 8 to whatever's in the y value. So in the first point, -7, -2, we add 4 to -7, and then we add 8 to -2, and we get that it will be at -3, 6. So we go to the right 3, and we go up 6, which is going to be somewhere off this graph, but somewhere kind of there. Then for our next point, -2, 2, we add 4 units to the x, and we add 8 units to the y. So -2 plus 4 is just 2, and 2 plus 8 is 10. So we go to 2, 10, which is going to be way off the graph. Oh, this point erased. It was -3, 6. So we go to 2, and then 10 will be way off the graph. Somewhere way up there. And that makes sense because this point is higher than this one. So if we translate it way up here, this point is going to be way off the graph. Then our next point is -2, -4. And we're going to add 4 units to that, to the x value, and add 8 units to the y value. So -2 plus 4 is just 2, and -4 plus 8 is just 4. So we go over 2, and then we go up 4, right about there. Then our last point, -7 plus 4, or -7, -4. Well, we're going to add 4 to the x, and we're going to add 8 to the y. So -7 plus 4 is going to give us -3, and -4 plus 8 is going to give us 4. So -3, 4. And we can see that we do have a translation of this original polygon here. And if we could go off the graph, you would see that this point is up there. Okay, so in this next question, we're asked to approximate the highest price of a gallon of milk, of whole milk, as shown in the graph which we're given, and then we're asked to identify the year in which the highest price occurred. So this is just basically just basic stuff, just looking at the graph and identifying where the highest price is in this case. And obviously that would be the point that's highest up on the y-axis, because the y-axis is measuring price. So higher up on the y-axis means it's higher up in price. So we can see that this point here is clearly higher than all these other points here. So this is where the highest price, or this is the highest price here, and we can see that it occurred in 2007. So we already know that 2007 is going to be part of our answer. And then when we're looking here, because it says approximate, we don't have to be too exact, but I would list that as anywhere from 385 to 387 per gallon. So I'm just going to write that down as 385 to 387. Anything in that range would work. 386 would work. But, you know, if you go 280 or 260, obviously that wouldn't. Or if you go 540, that wouldn't work either. Alright, so in this question we are given a graph, and on the x-axis we have years going from 2000 to 2008, and on the y-axis we have the cost. We have the average cost of a 30-second TV spot for the Super Bowl in thousands of dollars. And in the first part of the question we are asked to estimate the percent increase in the average cost of a 30-second TV spot from the Super Bowl in 2000 to the Super Bowl in 2004. And then we're asked to estimate the percent increase in the average cost of a 30-second spot from the Super Bowl in 2000 to the Super Bowl in 2008. So the thing we need to look at, let's answer this first part first. So we have to find the percent increase, or estimate the percent increase for a 30-second TV spot from the Super Bowl in 2000 to the Super Bowl in 2004. So the thing you need to know how to do is find the percent increase. And in order to do that, we have to find the difference between the two numbers. Then we have to divide the difference by the smaller of the two numbers, and then multiply that quotient by 100. So our two numbers are going to be the y value for the point where the x value is 2004, and the y value where the x point is 2000. So in 2000, our average cost for a 30-second TV spot is 2100. So we're going to do 2100, or I guess so for 2004 our number is 2300, so we're going to do 2300. And we know we're going to be doing subtraction because it says find the difference. And then our number for 2000 is 2100. So we do 2300 minus 2100, and that gives us 200. And then we have to divide the difference, which is 200, by the smaller of the two numbers, which is 2100. So we do 200 divided by 2100, and feel free to use a calculator for this. (200) divided by 2100 is 0.0952. I always go out to 4 decimal spaces, but your teacher might want you to do differently. So now we have to multiply that by 100. So we multiply 0.0952 by 100. And we get 9.52. So between 2000 and 2004, the average cost of a 30-second TV spot for the Super Bowl increased by 9.52%. Now in the second part of the question, we're asked to find the same thing just between the years 2000 and 2008. So in 2008, our number is going to be 2700. And since we're still using 2000, our number is going to be 2100 again. So 2700 minus 2100 is 600. And then we do 600 divided by the smaller of these two numbers, which is 2100. And again, feel free to use a calculator for this part. So our number is 0.2857. And then we're going to multiply that number by 100. And that's going to give us 28.57. So between the years of 2000 and 2008, the percent increase in the average cost of a 30-second TV spot in the Super Bowl increased by 28.57%.